Alright guys, welcome back. So today I think we have a really cool video. We're going to look at how we can detect certain images through the camera using the ARKit in iOS 11 and greater. So here on the screen I have my iPhone and I'll lift it up here and I'll go into our demo app. And as you can see here at the bottom, it shows us a prediction of what it's thinking that it is, along with a numerical value out of 1, and 1 out of 1 would be that it's certain. So let's take a look at a few images I've pulled up here. And the first is a banana. And you can see it's almost certain that that's a banana. And we can look at a basketball. And it's almost certain that's a basketball. And now we can take a look at a real example that I have here. So I have a Gatorade bottle. And you can see it's about anywhere from like 75 to 90% sure that it's a water bottle. So yeah guys, that's pretty cool. We're going to look into how we can build it right now. Alright, so the first thing to do as always is we're going to create a single view application. And I'm just going to call it something like image detector. And just click next and create. And I'm actually going to just make it full screen here. Alright, so to actually get the camera to launch right when the app opens, there's a couple ways to go about it. But the way I'm going to do it, I think, is to delete the storyboard. So I'm just going to right click and move it to the trash. And then in your targets inspector, under general, you just want to go to your main interface and just delete that and leave it blank. And essentially what that's going to do is it just loads up a black screen now. So now we need to go into our app delegate and we need to set the window. So right before return true and did finish launching with options, we're just going to say window equals UI window. And then we can say window dot make key invisible. And then lastly, let's just say let VC equal view controller, like that. And we also have to set the root view controller, and that's going to be our VC. Now we have our window set up, we're going to go into our view controller. And at the top here, we need to import two different things. So the first is going to be AV Foundation, and secondly, we need to import Vision. And the Vision framework is what allows us to use the camera and the ARKit essentially. So down in our view to load, we're going to call some kind of method that's actually going to launch our camera that detects objects. So I'm going to call it something like setup capture session. And down here, we're actually going to call that or create that function. So like that. And okay, so now that we have that, this is a little bit tricky. It's new with the ARKit in iOS 11. So I'm just going to go through it, and then at the end, after I have this function typed out, I'll try to explain it to the best that I know, and hopefully it makes sense. So the first thing we're going to do is call a variable. So let capture session equal AV capture session. And now we need to search for available devices or like available cameras. So I'm just going to say search for cameras. And so we can say let available devices equals AV capture device dot discovery session open bracket. And this is what got me, it had me tripped up for a while, and so I looked at the documentation, but essentially all you need here is sorry, I should delete this, and you just need to say built in wide angle camera. And you can use any of them really, but that's the one that I decided to use. And then we just want to say AV media type dot video, and the position is the back, and then he's got to call dot devices. So essentially that'll just get our back wide angle camera or our back camera on the iPhone. So now we have to set up a capture device and also add what's called a capture session to it. So I'm going to use a do catch. So I'm going to do like that, and after that, so up here I'm going to say if let capture device equals available devices dot first. Then I'm going to say let capture device input equal try AV capture device input, and then open, and then we just need to send it that capture device, and then we say capture session dot add input, and then we can just add that capture device input. And now I need to say catch, and then we'll just print out air dot localized description. So essentially what this is doing is it's creating a do catch. So it's going to create a variable called capture device, and it's going to be equal to our first available device, which is essentially this back camera that we created up here. And then once we have that, it's going to create a capture device input, and it's going to try to do that with this capture device. And then once we have that, it's going to take our capture session, so our AV capture session, and it's going to add an input, and it's going to add that device input right there. So now we have to be able to get a way to actually set up the output and add output of the session. So what I'm going to do here is just add some space, and I'm going to say set up output, and also add output to our capture session. So I'm going to create a variable, so let capture output equal AV capture video data output, and then capture output dot set sample buffer delegate, and it's looking for an AV capture video data output sample video delegate, and all you have to do is put self here, and as long as you go up to the top here and you add that AV capture I think it's this one. Oh, okay, there it is. AV capture video data output sample buffer delegate. It's a long one, but once you have that, then you can just put self down here. And in the queue, it's looking for a dispatch queue, and we can open this, and it's looking for some type of string here, and you can really pass anything. I'm just going to call it video queue. And then we just need to say capture session dot add output, and we just need to say capture output. And lastly, we need to create a preview layer so we can see what's going on inside the screen or inside the camera. So something like let preview layer equals AV capture video preview layer, and open bracket, and this time it's looking for a session, so we can just pass our capture session, and then we have to add our preview layer to the view somehow. So to do that, you go view instead of add subview, you have to be able to access the layer. So layer.add layer or sublayer, and then we can just say preview layer. And we also need to set the frame of the preview layer. So preview layer dot frame is equal to view dot frame. And lastly, we just need to start running the session. So capture session dot start running. Okay, so what this is doing, like I said before, it's just getting this is essentially setting up our input, so our cameras right here. We just went through that a little bit ago. And then this is creating our output. We need to actually be able to get the results of this capture now. So it's storing this. Now we need to be able to access the results. And now that we have this delegate up here, this AV capture video data output sample buffer delegate, we have the ability to access this function right here. So we can call did output, and inside of here, this is where we can access the results of our output. So the first thing we're going to do is we're going to create a model, which is going to act as what the code is looking through in order to pick out what images it thinks it is. So we're going to create a guard. We're going to go here, we're going to create a guard. I'm going to say guard let model equals try. And we're going to call vncore model, vncore ml model. And it's going to be 4. And we're going to throw in some type of variable here in a moment. Then we're just going to call else return like that. Okay, so what variable do we need to here is we actually need a model, so a machine learning model. And to get one of them, we're just going to go into Google here or Chrome, and you can just type in core ML models into Google, and it should be like the third or second link down, somewhere around there, but you're just looking for the Apple developer page. And when it loads up here, you want to click on working with models in the top right, and then scroll all the way to the bottom, and you'll see that they already have some models that are trained and developed. So if you read down, it'll tell you exactly what they do, but for the sake of this tutorial, we're going to focus on either this ResNet or Inception 3. I think we're going to go with the Inception 3. So yeah, what you do there is you just download this. Once done downloading, just locate the file, and it should look something like this with the little M and the L in the middle, standing for machine learning. So we'll just drag it and drop it into our project, and make sure you have it selected to the target if it's not already, and click finish. And it might take a couple seconds to pop in there because it's a little bit of a larger file, but in a moment it will. And when it does, you'll see it pop over here, and we'll be able to use it right here for this model. Alright, so now you see it's over here, Inception v3 .ml model. So here we can say Inception v3 open close, and then just call model. And basically that's a machine learning model, like I said, that's been trained to recognize millions or thousands of images. Okay, so now that we have that, we need to create some kind of request to request the results. And we're just going to call a variable let request equal vncore ml request, and it's going to ask for a model. And I'm actually going to go back here, and we're going to select the second one with the completion handler, if I can. I don't know why it keeps doing that. Okay, so now we're just going to pass in model, and for the completion handler you can just hit enter and something like finished request and then error. And then down here we're going to call a couple more guard statements just so we don't get any crashes. So guard let results equals finished request, finish request dot results as, and we're just gonna cast it as a type array with v, b, and c classification observation, else return, and then another guard statement, so guard let observation and that's going to be equal to results dot first, and then we just need to also return out of that. Okay, so if you're still with me, guys, I know it's a little bit of work here. The last thing we need to do is we need to create a pixel buffer, and a pixel buffer is basically a pixel holder, like I was saying earlier. But before we can do that, we're going to do one more thing here. So let's say dispatch queue dot main dot async, and inside of here we can for now just put print, and we'll just say observation dot identifier. And it looks like I spelled observation wrong up here. But now we should print out the observation. So after we do that, like I said, we need to go guard let pixel buffer, and it's going to be a type cv pixel buffer equal cm sample. Let's see what it is. Buffer get image buffer, and it's looking for a sample buffer, and we can just say sample buffer and return out of that. And then lastly, we just need to try, so try vn image request handler, and open bracket, and we're going to send this CV pixel buffer with options. And man, I do not like this new beta at all. I guess you have to click every time instead of tabbing, but so we're going to say pixel buffer, and our options, we can just go like this, and lastly, we just need to perform the request. Alright, so if we would run the application now, let's see here. Oh, we just need to put this in a bracket as well. Okay, so if we would run the application now, it would start predicting our objects, but we just don't have any way to display it other than printing it out. So I think the best way to do it is I'm just going to create two quick variables at the top here, and let's just go let label UI label, and then say let label equal UI label dot text color equals UI color dot white, label dot translate auto masking constraints equals false, label dot text equals we'll say guess, and label dot text alignment equals dot center, label dot font equals label dot font dot with size, and let's just say 24. And lastly, we just need to return the label. And I'm going to create the second label, so I'm going to copy and paste this whole thing. And this next one is just going to be called confidence label. So now we just need to set up constraints for our labels. So we'll go down here and say func set up labels, label dot censor x anchor dot constraint, and it's going to be equal to our view dot censor x anchor, and make sure you just set the active on all of these, so is active equals true. And similarly, label dot bottom anchor dot constraint is equal to view dot bottom anchor, and we'll just say something like -50 dot is active equals true. Label dot left anchor dot constraint equal to view dot left anchor is active is true. And lastly, label dot right anchor dot constraint is equal to view dot right anchor dot is active is equal to true. So up here, instead of just printing out this statement, now we can actually go back and say self dot label dot text is equal to observation dot identifier, like that, and then self dot confidence label dot text is equal to observation dot confidence. And okay, let's see, identifier, oh, down here we just need to actually call constant -50, and that should get rid of that. And confidence label dot center x anchor dot constraint equal to view dot center x anchor dot is active equals true. And confidence label dot top anchor dot constraint is equal to label dot bottom anchor dot is active equals true. Alright guys, so that's all the code. I know it's a little bit different and it's new for a lot of you. I'd really recommend reading the documentation on a lot of these different models. Even myself, I have to do it still. I know what they do and how to set it up, but I don't necessarily know the entire workings of it. But if you would run the application now, you'd get the exact thing that I showed you in the beginning of the video. So I hope you guys enjoyed, and I'll see you guys next time.